Hello guys and welcome back. So I have a few frames here that finished rendering, and this is how the quick effects looks like. You can see the layering there. I think it's very cool, and yeah, this is a huge workflow that I use a lot to create a variety of things. Actually, anything that is point based where I need to use points and render the effects, I would first try and come up with a procedural workflow that doesn't require a sim. And so this is something that I use a lot, and I'm going to show you a continuation of this that hopefully will give you some more ideas on how we can create procedural effects. This workflow can be used to create shields, like energy shields can be created to create any kind of impact or radial blast. If you have, for example, some magic or a mage doing any magic spells, you can have that force the radial sphere expanding, and this is how you would approach it. You can also create a shield of various energy layers moving through to protect a character, for example. That's the kind of effects you can create. And I'm going to show how to make use of the NURB surfs to create some of these effects. It's actually very, very simple. So I'm not going to copy anything. I'm going to create a new GeoNode, and I'm going to create a circle. Same thing. Okay, I'm going to change it to a NURBS curve. I'm going to change it to open. I just need the curve. I'm going to copy this and scale it to 1.5 like before. I'm going to merge them, and I'm going to use an operation called skin, and what it does, it links two curves, two NURB surfaces together with geometry. So I'm going to put down a skin. It works with any curve, NURBS or not. If you have an input as an NURBS, it will give you a NURB surface. Now, what's the advantage of these NURB surfaces is that they're parametric surfaces. So we can generate a perfect UV coordinate on any UV mesh because it's parametric. Each point is described as two coordinates, U and V. So it's very easy to compute a perfect UV coordinate for this, and we can do that using the texture, UV texture node. I'm going to set it to rows and columns. I'm going to set the point attribute, the UV attribute, to be points. Okay, so we have that. I'm going to put down a color node, and I want to visualize that. And I'm going to create a ramp from attribute. I'm going to type in UV. You can see we have red going this way and green going this way, clockwise. And this is the guy that we tried to create using the fit range before. So we could have used this simply instead of doing the other way. But I want to show you guys a variety of method and teach you a variety of ways to do things in Houdini. So with these, we're going to create a noise based on the UV coordinate. And again, I don't want to change this. I like the surface. I'm going to keep it. I'm going to scatter some points on it. And this is a great feature of the scatter node has, which is it inherits the inputs. It resamples where the point is at that surface, and it inherits all the attributes. So if we create anything, that will be passed along as long as it's a point attribute. And this is the points from the NURB surface. And we're going to create a point vol. I'm going to override the color, or actually let's create a new color. So let's turn this off. I'm going to take the uv.x, so vector to float, and let's take a look at that as a color. So that's the clockwise coordinate. Let's take a look at the y information. And I want to create a color based on this. So let's create a mix node. I'm going to mix between two colors. Let's do a light blue and a darker blue. Let's inverse them. So let's copy this, right click, paste values, and let's change this here. Okay. And I'm going to use the UV coordinate to generate a noise pattern. Actually, let's look at it in the viewport. I want to see it as the color. Let's do that. And I'm going to set it to 3D noise because I want it to be based on, I want it to be a color. So scaling the frequency, that's great. And let's scale the frequency of each axis individually. And something is bugging me right now. The distribution is not perfect here, so what I'm going to do is I'm going to go back to these guys and increase the division to get more details there, and that should help with this, with the distribution. Okay, let's go back up and increase the point number. Okay, so we have almost the surface now. And let's increase the frequency one by one. So this is the first axis. Let's set it to 100. Okay. And this is the second axis, which stretches it along this angle. This is very, very, very powerful. And you can see by increasing this, how it's repeating the map. It's not repeating it in a random way. It's repeating it along this clockwise, and this is very, very cool. And what we can also do, we can generate, let's plug in that color, and let's use this as an offset. Let's take a look at this. So I'm going to add the offset, and I want to make it, let's not do that now, it's fine. So we'll do the remapping next week. So I'm going to increase the noise, okay, and I'm going to use these offsets, so not that. That's too much. Let's go slower. And you can see the pattern is moving outward very, very nicely. And we did this before, but the pattern was not aligned in this direction. This is how you would do it properly. And this can easily be achieved using the NURBS information, the NURBS UV coordinate. So let's expose these guys. Okay, let's do that. And I also want to do one more thing. I don't want to disturb this part. I want to leave it as it is. I want to disturb it as it gets further away from this. I want it to get disturbed. And what we're going to do is we have the original position. We have the new position. We just need to blend between them. So we can use a mix node. This is my disturbed position. This is my original position. And I can choose 0 means full deformed, 1 means the original. And we can use this the UV Y coordinate as the driver. Oh, this looks like an iris. If we scale maybe this, we could get. Yeah, so we can create an iris like this. Very cool. Okay, so let's go back. So I want to mix this. I want to do the inverse. So right now it's inversed. Let me copy this. I like this. I'm gonna do different effects with that. So I'm gonna swap these two simply. This is going to be P. That's going to be my deformed one, and that's my circle intact. Let's go back up. And now if we animate this, minus $F divided by 5 so it doesn't move too fast, we get something like this. Very, very cool. And if we render this, obviously, with motion blur and everything, it's going to look even better. So let's do a trail. Yes, you know it's... Okay, let's do a trail. It's compute velocity. And let's do another trail. So this makes a copy of the mesh, and it from the previous frames. Okay, I will investigate this later. Cool, so now we have the velocity motion. Look at that. We have some really cool motion. Okay, let's increase the point count. How much do we have now? 600,000. Let's do 3 million. And you see it's stopping from generating the points. It's giving us an error, and the reason for that is because we have this max thing. Let's turn that off. And there we go. Let's set this to dark. And I want to do a test frame, show you guys how it looks like from close up with motion blur and everything. So what do we need? Let's copy this like before, same settings. Let's make sure we have the P scale set. We don't have to, but it's easier to tweak. Let's do a quick render. Pardon me. Cool. So this is one idea to create some cool effects using just points. And let's turn off a few things. This is the raw colors. Okay, let's lower the point size to 0.6. Do another render, take a look at that. The cool thing, you get to see the velocity stretching, and it's very interesting in a lot of cases, and this is something very hard to see. And when I do effects, or especially particle based, I always account for this, so always keep that in mind whenever you do an effects. Okay, let's do one more thing. So we have 33 million. Let's try something crazy. Let's try 30 million. See, it's cooking now. It's generating the points. Come on. And it's taking time. Longer than I expected. And it's gonna generate 30 million points, but with I need to wait for it. When it comes to particle that are point based, we don't have to do it all at once. So this is the points. If I zoom in, you can see how much points we have. Let's do a close-up render while I talk about this, if it can finish. So when we do particles that are point based, like this for example, whether it's a sim or not, we don't have to do the entire sim at one time. We don't have to do it to do 10 million or 30 million points at the same time. All we can, instead of pushing all that data through the memory, we can cluster it or do smaller chunks at a time and then combine them together. So for example, for 30 million, I would do 5 sims, each with 6 million instead. And every sim, I would change this global seed here, so the points are not the same. By changing that, the points are not the same anymore. And then you can run 5 different sims, each on a separate machine, and they will finish, and then you combine them back again to create the 30 million points. So, but it's still, with this workflow, it's feasible. So let me lower this to 1.5. Cancel this guy. And this is very high res. At 30 million is a huge amount of points. to work with, and you can see that already in the viewport. And at this level, you're not going to see any, you're just going to get smoke-like feeling for this effect, especially if you add transparency to it, which we will do later. So let's go back. I'm going to let that render and talk about this concept again. Let me lower this to 3. And instead of jamming 30 million points to memory, we can do 10 sims, each one with different seed. Okay, so I can copy this entire chain. Let's just do that first. So I can copy this, leave it at 3 million, and then change this to 10, or we can link it to an input or something that changes the value with every sim. And this is a much more efficient way instead of having to process all the data at once. And this is the render with 0.02 whatever value we put in at a close-up. You can see how cool this is with just the top level stuff. So okay, let's continue. I like this. It's very, very cool. Let's do 3. Let's do something lighter. And I left this copy on purpose. And what I want to do is let's see, is this moving? Yep, this is moving. I want to create another version that moves on the opposite direction. And I want to give it different colors. Let's do orange and darker tone there. Okay, I'm gonna copy this. I want the seed of points to be different so they don't overlap. I'm going to merge these together. And here we have this guy moving in one way. And I want this guy to move faster 2 times and inside. If we hit play, maybe it's too much. I'm gonna lower the noise here. Yeah, something like that. Sorry, I want it to be 2 times slower, not faster. Cool. So you get one layer pushing outward and another layer pushing in, and we can mask these. Actually, let's mask it now. It will look cool in the viewport. So we can just set it to black, and that will hide it from the viewport. And we can also do the inverse of this. Instead of this blue here, the dark, we can set it to black as well. And now the 2 layers are fading in and merging together. Cool. So you can, let me transform this so you guys get the idea. And there's some Z depth issue, because the viewport cannot handle this nicely. And let me change this, the display. I'm going to increase the sampling. You can see how it's changing as well. And let's do a quick preview of this, just to give you guys an idea. Cool, so you can see one layer moving outward and a second layer moving in, and it feels like it's wrapping around something. Just with the illusion of this gradient here, it feels like it's rotating, or it's creating a circular motion. And this you could use this for a portal-like effects, or any energy, or a plasma from a gun. You want to create a radial blast, you can do that using these techniques. Cool. Let's take a look at this 30 million close-up version. And it took 1 minute, 1.727 minutes. And I have some other stuff running on the background as well. Cool. Thank you guys for watching, and see you in the next video. Bye bye.